Today we are starting a new unit, and it is on two-dimensional figures. So we're going to start by discussing some angle and line relationships. And so within this section we're going to talk about some different angles specifically. I know you've talked about perpendicular and parallel and those sorts of things, but we're going to go a little bit further and kind of prepare you for that geometry piece that you'll get to in a couple of years. So first off, I want to start by talking about vertical angles. So vertical angles, I'm not sure if you've heard of these or not. I'm guessing you maybe have. But they are pairs of opposite angles formed when two lines intersect. So I've given you an example of when two lines are intersecting. And I've labeled the angles 1, 2, 3, and 4. So those aren't angle measures, those are actual labels of the angles. I've just named them 1, 2, 3, and 4. The lines that are opposite, the angles that are opposite from one another would be angle 1 and angle 3. So this angle and this angle are opposite, and they're formed by those two lines intersecting. And then 2 and 4 are also vertical angles. So angle 2 and angle 4 are vertical. And so I'm going to label those actually with double arcs in here so that they're different. And if you really look at those angle pairs, you'll notice that 1 and 3 are congruent, 2 and 4 are congruent. So that's not necessarily what we're going to get into today. We might get into a little bit in the homeworks and things, but with these, you do want to notice and kind of recognize that vertical angles will always be congruent to one another. So 1 and 3 are vertical angles, 2 and 4 are vertical angles. Now adjacent angles, we know the word adjacent means beside. So there are two angles that have the same vertex between them, share a common side, and do not overlap. So looking at the same angle picture, adjacent angles, we could say that we have angle 1 and angle 2 would be adjacent. You could say that angle 2, making it look more like an L than an angle. Angle 2 and angle 3 would be adjacent. So anything that's side by side, so 3 and 4, 4 and 1, those are all going to be adjacent angles. So those are not necessarily going to be congruent. They're just side by side, and they share one of the sides of the actual angle itself. So let's take a look at a couple of more definitions. Supplementary angles are two angles that are going to add to be 180 degrees, and complementary angles are two angles that are going to add to give you 90 degrees. So for instance, two supplementary angles would look something like this. So one's going to go this direction, and then another one, when it's completed, if I were to put those side by side, they'd add up to exactly 180 degrees and it would be a full line. Complementary should form a right angle if they were touching and side by side. So these two would be complementary, because again, if I put those side by side and made them adjacent, this is all going to give us the 90-degree angles. So supplementary, 180 degrees, complementary, 90 degrees. Alright, and now I want to talk about a few other angle types. We know what parallel lines are, so I'm not going to go through and define those. But we are going to use some parallel lines here. And this line that cuts down through is called a transversal. So it's a line that cuts through two or more parallel lines. So this line here cuts through these two parallel lines, and so we call that a transversal. Now the transversal actually creates several different angle types and pairs and sets that we're going to look at. The first one, so if I number these, 1, 2, 3, 4, 5, 6, 7, 8. So we really have two different groups of angles. We have this group up here and we have this group down here. We're going to relate these two groups of angles. So the first one that we have, the first group that we have, are called alternate interior angles. Alternate interiors means they're inside the parallel lines and they're on opposite sides of the transversal. So angle 3 and angle 5 would be alternate interiors because they're on the inside of the parallel lines. They're in between them, but they're on opposite sides of the transversal. There are two other alternate interior angles, and that would be the 4 and the 6. Now, if we have alternate interiors, we also have alternate exterior angles. Now, alternate exterior angles are going to be just that. They're going to be on opposite sides of the transversal, but they're going to be on the outside of the parallel line. So, for instance, 8 and 2. Opposite sides of the transversal on the outsides of the parallel lines. So one example would be angle 2 and angle 8 would be alternate exterior angles. And the final one that we have, the final angle sets that we have are called corresponding. So we have alternate interior, we have alternate exterior, and we have corresponding. Corresponding angles are going to be in the same spot in each of the two sets. So for instance, which one would be corresponding to 2? Well, if you take this and you overlay it here, which one's in the same relative location? Well, that would be 6. So angle 2 and angle 6 would be corresponding angles. Also 1 and 5, 4 and 8, 3 and 7. So there are 4 pairs of corresponding. There's 2 pairs of alternate interiors and 2 pairs of alternate exterior. So I'm going to draw a new picture up here. We're going to do an example. We're going to label some things with these different names and terminology labels from this bigger picture. So you can call this example 1 if you wish. So we have parallel lines this way. And then we have actually 2 transversals. So one going this direction and one going this direction. Now if I label these angles, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, and 16. So the first question that they have is to classify the relationship between angle 3 and angle 5. Well, if I label these, if I mark these on my piece here, we have angle 3 and we have angle 5. So notice, what's their relationship to the parallel lines? Well, with these two parallel lines, they're both on the inside, right? They're in between them. And they're on opposite sides of the transversal. So they're interiors and they're on opposites. So these two angles would be alternate interior angles. Alternate interior angles. Now, something you want to know about those angle pairings. Alternate interior angles are congruent. Alternate exterior angles are congruent to each other. And corresponding angles are congruent to each other. So each of those angle pairings that we talked about are all congruent. Okay, now exteriors are not congruent to interiors, but the two interiors are congruent. So for instance, 3 and 5 are the same. 2 and 8 would be the same. What do we notice about 5 and 8? It's supplementary. And then corresponding, 8 and 4 would be congruent. Okay? So if I tell you the measure of angle 1 is 120 degrees, find angle 3 and angle 5. If number 1 is 120 degrees, so now we know this is 120 degrees. What's the relationship between angle 1 and angle 3? Well, these are intersecting lines. They're opposites, so they're vertical angles. So we know this is also 120 degrees. Well, if this is 120 degrees, that means number 5 is also going to be 120 degrees. Now, if this is 120, that means this would be 60, which means 8 would be 60, which means 6 would be 60. So then the pattern continues. So really, between the two sets, between this set and this set, there's only two different angle measures. There's 120 and there's 60. And the angles are all going to alternate. 60, 120, 60, 120, 120, 60, 120, 60. So there is a pattern that you can find as you go throughout this process. So that's all the further I want to take this today. So we will do some more work with this, and we'll elaborate a little bit more on the alternate interiors, exteriors, and correspondings. And we'll work a little bit more with parallel lines and transversals in class.